Hello everyone, welcome to the sessions on the advanced communication, and this is the session 6 in the unit 1, and in this particular session we are going to learn about the reflex Klystron tube. The contents which we are going to cover, first one is the reflex Klystron tube construction, working and the applications. In the last session, we have studied about the two-cavity Klystron amplifier. But that two-cavity Klystron, it is nothing but the amplifier there. But this reflex Klystron, this is an oscillator. Reflex Klystron is an oscillator. Therefore, reflex Klystron is a low power, low efficiency microwave oscillator. That is, it is generating the signals. It is not amplifying, but it is generating the oscillations there. Therefore, it is the microwave oscillator circuit here. Now, the construction diagram, if you observe here, in the previous session, that is the two-cavity Klystron amplifier, we had the two cavities there. One is the buncher cavity and other is the catcher cavity. Correct? In the buncher cavity, we have applied the input, and in the catcher cavity, we took the output there. But since it is an oscillator means what? Whether we have to apply the input there? No, because we are not applying any input for the amplification and all. It will generate the oscillations by its own here. It is generating the oscillations by its own. Therefore, it is an it is having only one cavity here. If you consider the constructional diagram here of the reflex Klystron, again this is the cathode here which is generating the electrons here. It is the cathode, it is generating the electrons. We are having only one cavity that is called as the anode. We are having the only one cavity that is called as the anode here. And here we are having, if you just observe the polarities here, the anode is at more positive voltage compared to this cathode. The anode is, this cavity is at more positive because positive terminal is connected to this cavity here. Therefore, it is at more positive voltage compared to the cathode here. And if you consider this repeller, this is the repeller here. It is at more negative voltage compared to this one here. Means compared to the anode, this is at more negative voltage here. Repeller, the polarity, just go through the polarities here. The positive is connected to cavity means the anode is at more positive voltage compared to the cathode here, and this repeller is more negative because the negative terminal is connected here. To the repeller, the negative terminal is connected. Therefore, it is at more negative voltage compared to the cathode here. These are the important here because depending on these polarities only, the bunching will take place now here. The velocity modulation is taking place. Now, this is the repeller here. Now, this is one cavity where through this anode cavity, we are taking the output oscillations. We are taking the output oscillations, and same as usual, the cathode is generating the electrons here. The cathode is generating the electrons. Now, when the electrons are generated here, what will happen? Just observe here, when the electrons are generated here, those are attracted by this particular cavity because it is at very high positive voltage. Electrons are negatively charged particles, and when those electrons are generated here, those are attracted towards this cavity because cavity is at very high positive voltage. Therefore, those are accelerated and they will move with very high velocity. They will move with very high velocity, and when they are reached here with their high velocity, they will cross this gap. Those are accelerated in such a way that their velocity will crosses this gap and they will reach here. They will reach here, but they cannot reach the repeller. This point they cannot reach. Why? What was the reason? Because it is at negative voltage. Repeller is at negative voltage. Therefore, when the electrons are generated here, those are attracted by this positive voltage of the cavity. They will move with very fast or very high velocity. With very high velocity, but after some time they are again the repelled by this particular repeller here. Retarded means they cannot reach either because electrons are also negatively charged particles and this repeller is also at a negative voltage. Therefore, those are retarded. Again, they will come back. Again, they will come back here. Now, during this coming back, the bunching of the electrons will takes place there. During this coming back process, the bunching of the electron will takes place. Once again, I will explain. That is, in the cathode, when the electrons are generated, what will happen? Since the anode is at very high positive voltage compared to the cathode, these electrons, negatively charged electrons, are attracted towards this anode. Therefore, they will start moving with very high velocity. Now, once the particular they will reach here, they are moving with very high velocity here, but they cannot reach up to this point here. Why? Because it is at negative voltage. They will reach here, again they will return back. Because of this negative voltage here. They will return back here. Now what will happen? When now, as we have explained, this is the oscillator here. Oscillator means what? There is no any input signal. Only we should take the output here. We have not applied any input. But initially, to generate the oscillations, we should assume that one small noise signal will be there. To generate the oscillations, initially for any oscillations, we have to assume that in the circuit here, one small noise signal will be available. Now this noise, due to this field here, the bunching of the electron will take place here. Means this input we are not applying here. We are not applying any input here. But this we have to consider on small signal RF field will be there due to the noise here. Due to the noise, the RF field will be there. Now what will happen? The bunching, just see here. Now again the same, this one here, this is the reflector, this is the output cavity here, this is at more positive voltage here, and this is at more negative voltage here, and this is the electron gun which is generating the electrons here. Now these electrons are attracted by this positive, therefore they will move with very high velocity, and they will shoot out. This means they will crossing this gap and they are coming here, but they cannot reach here. They will, here only they will return back here. Here only they are returning back. Now see how the bunching will take place. Now consider 3 electrons are there. One is this one here, this one, and one more. Suppose A, B and C. Electrons A, B and C are there. Now the electron B is coming. Here. If you consider this is electron B, when it is emerging, when the noise signal is 0. When the noise signal is 0, at that time the electron B is coming. Therefore, it will move and it will reaches at some point here. Suppose this is the repeller here. This is the repeller will be there. It will reach up to here. Correct? Because it is the noise signal is 0 at that time, or the field is 0. Okay. Now consider one more electron, that is A. Electron A. Now electron A is coming earlier than B. Before B, electron A is coming. Correct? Before B, only electron A is coming. But when it is coming, when the that field is positive, noise signal is positive there. Therefore, noise signal is positive means what will happen? It is accelerated. The speed will increases. If the speed will increases means, suppose this is electron A is reached up to this point. Now one more electron B is coming. Whether it will covers only this much distance or it will crossing this distance. See here, electron B is coming. Compared to electron A, its velocity is very high because it is accelerated here. Therefore, the electron B will crosses this and it will reach the higher distance here because it is having the higher velocity. This is the electron B here. Okay. Now see, consider the electron C here. The electron C is emerging when the field is negative. Correct? When the field is negative, then what will happen to the electron C? It will be retarded there. The electron C will be retarded. Therefore, it will cover much smaller distance here. It is covering much smaller distance. Therefore, whatever the particular distance covered by these all the 3 electrons, while returning back here, all the 3 electrons A, B and C, A, B and C, they will catch up with each other and the bunching of the electron will take place. The bunching of the electron will take place, and those bunch of electrons, they will give their energy to the particular field, and the strength of the field will there increases and the oscillations will be generated here. Therefore, here the electron A, it is coming at the positive voltage, means this is the A here. It is coming at positive voltage, means it will cover more distance here, and this is the electron A. This is the electron A. Therefore, electron A is covering more distance, and this is the electron B. It is covering one more distance less than A. Why? Because A is at accelerated here. This is A, and this is B, and one more electron C. It is covering much lesser distance. Why? Because it is retarded here. Because it is retarded. Therefore, all are covering different distances here, and therefore, while in their return journey, all the three electrons will catch up with each other, and the bunch of the electrons will take place here. Therefore, they will provide their energy to the particular field here. This is the principle of working of the reflex klystron oscillator. Now the applications where this particular oscillator is used, that is in the signal source in the microwave oscillator. In the microwave, wherever we need the signal source, it is used as the source here because it is generating the oscillations. Next is the local oscillator in the microwave receivers. Frequency modulated oscillator in the microwave links. Pump oscillator for the parametric amplifier. These are the some of the applications for that particular oscillator.
Reflex Klystron. It is a single cavity variable frequency microwave generator of low power and low efficiency. The electron beam is accelerated towards anode cavity. It is an evacuated tube and consists only a single cavity. It is a reflector or repeller, and an electron gun consists in which two voltage used, in which one is repeller voltage which is connected with repeller or reflector, and another is anode voltage. One cavity, it is take as a anode and consists positive charge, and repeller connected with negative charge of battery. Electron gun spread electrons, and these electrons move toward anode cavity, to whom we take as a anode. Electrons take a negative charge, and anode carry a positive charge. Two voltage used, one is repeller voltage, one is anode voltage. Anode, this cavity we took as anode, and repeller connected with a negative charge of battery. Electrons starts move toward anode, means to say cavity, but some electrons move ahead to repeller. But repeller connected with a high negative potential, so repeller repel the all electrons backward direction. Anode voltage, means to say voltage we connected with the our cavity. It contains positive charge. Anode voltage used to track the electron beam toward cavity, and repeller voltage is applied to repel the electron beam due to the supply apply. It is a switching voltage used as input voltage. Repeller repel all electrons backward direction because negative charge, electron contain negative charge, and repeller also connected with negative charge. Negative repel to each other, so electron repel and move backward direction. Anode connected with positive charge, battery positive charge connected with the cavity. So electrons attract toward the cavity, and RF output we can take from cavity. So this type reflex klystron work. If we talk about this apple gate diagram, three of electrons, earlier electrons, reference electrons and later electrons, all electrons bunch together and come from RF output as an amplified signal. We get all electrons bunch and output take from RF output signal, and these signal we use for communication. Or if we talk about its operating characteristics, which is draw between repeller voltage and anode voltage. The earlier mode large the output power, which is an advantage, but the voltage is required are also higher, so leading of installation problem and possibilized low efficiency. And mode is corresponding to like that. It shows operating characteristics. It is shown by T is equal to n plus 3 upon 4, and n is equal to any integer 2 or 3 and most widely used. So its operating characteristics show our wave according to our waveform 5 plus 2 upon 4, 4 plus 2 upon 4 and 3 plus 3 upon 4 and rise so as. That is the operating characteristics of reflex klystron.
Okay, in the next session, we'll learn about the TWT. Thank you.